Cute. Hello, Gophers. Hello, Londoners. How are you guys doing? Welcome to the final session, the closing keynote. Ooh, Q. Today we are going to learn about zero trust security for your APIs. It's a general topic. I know all of us, we are dealing with APIs, we're dealing with security. So let's get them together and see what we have today. With that, brief introduction about myself. I'm Akshata Sawant, based out of London. I'm a developer advocate at Salesforce. I'm mainly into MuleSoft integration, APIs, and security. I'm an author, a blogger, speaker. I love traveling, photography, and I'm a big-time foodie. I would love to connect with you guys over the socials as well. Moving ahead, OK, yeah. The agenda. So today we are mainly going to learn about zero trust security for your APIs. How do we secure our APIs using zero trust security? No matter what APIs we are using, REST APIs, SOAP APIs, if you have built using Golang or any other languages, doesn't matter. And security, the framework, zero trust security, it's like a common base framework. And we'll also have a quick demo. And I have prayed my demigods today. Also, if you guys have any questions, we'll address them towards the end. We do have some time slot for the question answer as well. All right, then, let's get started. So yeah, Rome wasn't built in a day. We all have heard about it. But it was taken to ground in a night, kind of. So that's the thing about empires, right? They're fragile. And just like that, it goes the same for trust as well. It's very fragile. And we can extend the same analogy to our enterprise ecosystems. So it takes massive efforts and lots of time to build an organization, to build an enterprise. But one small security mishap is enough to break everything into ground, to shatter everything, or maybe to destroy. So any GTA fans here? Oh, yeah. I can't see. The lights are really blinding. But yeah, there are quite a few. So last year, around the same time, around September, October, I guess, we had this incident where the GTA 3 game was about to be released. And just a few days before the game was released, there was this news that the game has been leaked in the market. There were videos and pictures everywhere. There were memes. And that was actually that was a big incident which brought that company quite a lot of destruction. There was a lot of damage in terms of reputation, money, financial, and everything. There was also a news that someone, the person behind this, or the one who bought everything, was actually someone internal to the organization who has leaked the information. So imagine someone within an organization has a power, capability, or maybe potential to do something destructive at this level to bring your organization to grounds. So the question is, whom should we be trusting? Whom? Yeah. So the answer is trust no one. And that is the underlying principle of zero trust security as well. So zero trust security is actually a security framework. And it's not applicable only to APIs. Like today, we're going to see about APIs, but it's actually applicable to enterprise architecture, integrations, to different frameworks, basically, whichever ecosystem you're working on. Okay? And the baseline is trust no one and always verify. That is the tagline, motto, or the main principle of zero trust security. Okay? Moving ahead, what have we been doing? Zero trust security it's not quite new as well. It's moderate, but it's been quite often it's widely used. So what we have been doing before zero trust security, what were the approaches we were having? So as I said, the underlying principle is trust no one and always verify. But before zero trust security came into existence, we have been using perimeter-based approach. So I know we'll be talking about security procedures, security protocols. Basically, there are two models we are talking about. One is the perimeter-based security and the zero trust security. So as the name goes, perimeter-based security is something like, let's say this is an organization, and once we have an ID card, OK, I'm not wearing mine, but once we have an ID card, we have access to the premises, and we can enter basically any rooms. So we have lateral access. And that's what is perimeter-based security. But when it comes to zero trust security, at each and every stage, like suppose if you want to enter this room, you have to like validate and authenticate at the entrance level, okay? Or to another room as well. So basically, at each and every level, you will be authorized, authenticated, and that is zero trust security. So these are two basic models. Like the one is perimeter, which is like traditionally used, and it has lateral access, and everyone can, like once you have an access to an organization, a system, you are basically allowed to go anywhere. Now, let us go back and let us relate this with our API ecosystem or your integration ecosystem or the microservices, basically any of your ecosystem you're working on. So you must be traditionally using, like if one person, if they get an access to their APIs, they can basically, or maybe an entity or any backend system, they can basically have access to other resources as well. So they can just do read, write, and all the operations. But at zero trust security level, you're actually going to verify, validate at each and every stage, each and every level. So there might be different endpoints, there might be different, what we call it, like different paths, but all of them will be like authenticated, validated, and only then you'll be giving the access. So we'll see, like, how do we implement zero trust security? What are the measures we need to take into consideration? And let's keep in mind that this is going to be like generic for all the Gophers or any other. I mean, basically, if you're building an API or trying to implement security, this is applicable for all the systems. Okay. So what are the core principles of zero trust security? The underlying tagline we have heard, like, it's never trust and always verify. But there are 4 major pillars of zero trust security as well. So the first one, yes, never trust, always verify. So no matter whoever is like trying to access what the persona is, it could be a CEO, it could be a developer, it could be anyone in your organization. They need to be first validated, authenticated, authorized, and only then they'll be getting access to the particular resources. We can implement this by using different protocol security mechanisms like multi-factor authentication, or we have different authentication levels, right? Even when we want to gain access into our organization system, we usually have multi-factor authentication. We have been dealing with Okta and all these different measures. So similarly, we are going to like validate each and every entity at every level. The next one, least privileges and by default deny. So we all are working with Google Docs, and whenever we are sharing a document with someone, we usually get these 3 options, like commenter, editor, and just a reader kind of thing. So by default, we should be having, like, the person outside, she shouldn't be having access to any resources, and we should be making sure that we are giving the minimum privileges. Like, instead of giving the entire read, write, edit, and all, we'll be giving the minimum privileges, like just the read one. The third one, full inspection and visibility. You need to be having a control, transparency, and visibility across all your data systems, underlying architecture, like where your data or where your APIs, how your APIs are, what is the flow of your API, how is the data flowing in and out of the systems, kind of thing. You're going to have a control visibility over your systems. And how you can achieve this, that's the 4th principle. Like, you're going to have a centralized management system, okay, where you'll be managing all your APIs, all your underlying architecture. So it's going to be like a one-place stop for managing all your APIs or basically all your systems. So we'll also see these things in terms of demo, like a live demo, like how we can implement zero trust security. But having a centralized architecture, centralized management system, it's going to help you with, like, suppose if you're having like around hundreds of APIs, so having a full control over them, of complete visibility, centralized management is something quite essential, and that's also a core principle of zero trust security model. If you're someone actually into security domain, or if you're like building security infrastructure, so you can actually you can use these 4 principles and you can proceed with your security implementations. So as I mentioned earlier, zero trust security is actually applicable for different, like you can extend it to different infrastructures, your organization security, or your different devices, basically. But today in particular, we're going to talk about APIs, like how are we going to implement them only for your APIs. So all of us, we are dealing with APIs, right? I just had a few conversations with a few of them, like while you were having coffee. Like, yeah, they have been building APIs using Go languages. So I usually build REST APIs using MuleSoft. I have built like there is a RAML or OS language, the API specification language, and I'm sure like all of us, we are using different languages to build API. But again, the underlying principle remains the same. And with a lot of advancement in technology, like we are almost like all of us, we are building APIs, we are using, consuming APIs. There is a lot of transaction going on. And it's actually recorded that 41% of organizations, they have been like quite under the threat of API security, API breaches, the security threats basically. So yeah, how do we resolve them and how are we going to implement zero trust security? So first we have studied like what is zero trust security and what are the different model, what we have been using historically. Moving on to the next, or the part two, I would say, is how do we implement it? So suppose if you're building your own security infrastructure right from scratch, so you must be having some existing stuff present, right? You must be having some existing infrastructure or some kind of security already present. So you do not have to build everything from scratch, or you do not have to scrape out whatever is existing as well. You can build on top of it using keeping in mind the 4 principles which we spoke about, the 4 pillars of zero trust security. So here you can see some Lego blocks, and that's the main theme, or that's how we are going to build our security model. So you can consider your APIs or different systems to be individual. We are basically going to divide our whole infrastructure, our whole ecosystem, into some small fragments. And then we are going to apply security on each of these fragments individually, and that's how we protect our total infrastructure or our total security level. So let's consider our APIs, like let's keep this image in our mind, and we can proceed ahead with the security thing. So what are the 4 principles and how are the underlying methods going to be? So when I say about never trust, always verify, we are going to have the security models like MFA or multi-factor authentication or single sign-on, SSO, as well. So you're basically going to authenticate each and every entity at each and every level. Moving on, least privileges, and by default, now you need to be having like a list of all the external systems, all your APIs which you have, all the end system, the databases. So once you have a list, only then you can manage what are the privileges or what are the access rights you're going to give. Okay. Third one, again, the full inspection and visibility. Whatever payload you're logging, okay, sometimes we might be having some payment gateway systems or some critical information like the personal information as well, PII information. So you need to ensure that you're having a control on the kind of payload that you're logging, and you're not logging any sensitive information, or it's not been tracked during the monitoring activities. And also the person who's like, we need to be having a full control, as I said, a full transparency from where the data is moving to and from the systems. And the last one, a centralized management systems. Here you can be having API gateways. So I'm sure like all of us, we are, like if you are into API management, so you might be using some sort of API gateway, or you must be having some provision. So that basically kind of be like a provision for centralized management, where we are keeping a track, privileges of access, we are having alerts, monitoring, and everything at one place for all our APIs. Moving ahead, so yeah, how do we have a layered security? So when we spoke before about the Lego blocks, so consider this as your, how many of you guys are using microservice infrastructure here? Yeah, so they're quite a good number. So we can imagine like we are having a mesh-like architecture, okay, a microservice architecture where we are having different APIs. Here you can see, like, consider the M blocks as APIs, and we are having different systems, like there is SAP, Workday, there is Salesforce, NetSuite, databases, and in-house databases kind of thing. So all of them, they're connected to interconnected in a mesh-like architecture. If you can see, there is a red dotted line, the outer peripheral edge. So that could be something like a perimeter-based security, which is just at the peripheral level, at the external boundaries, which is providing security just as a single layer. But if you see something, oh, I have a laser as well. If you see something inner block, like the one for the inner dotted lines, so that is something going to give you zero trust security. Like you're going to have security parameters at each and every level. Here, we can take an example of, suppose I'm having a payment gateway, a payment API basically. So for payment API, which is going to be like very crucial and important one, I'll be applying some critical policy or some security policy like JWT or basic, I mean, a higher level of authentication like OAuth or something like that. But suppose if I'm having just a get API call, which is going to return some public records for me, for that I don't need to have a multitude of security, or I do not need to have like a super quality, a high level security policy like JWT or something. For a public API, I could be having a simple, what we can have like the rate limiting or rate limiting kind of policy to protect it from like the DDoS attack, denial of services attack, basically. So we need to like at zero trust security level, at each and every level. Suppose if this is the way, uh, this is a microservice mesh, like where there is an interaction. At this level, I'm going to have a security policy at each and every level, wherever there is an interaction. Based on the requirement, we are going to have some kind of security implementation. And that is the underlying principle, and that's how we are going to have a zero trust security implementation as well. So you can see just one inner circle, but imagine having this for like all of the systems, all of different endpoints or joints, basically, wherever there is an interaction or transaction. So yeah, this is again an extension. Like suppose if you are having a different or service mesh kind of architecture or your architecture, I'm having different policies. I have a rate limiting SLA-based policy at the top layer, then I have some custom policy as per my organization's custom need. These are basically all the security policies. Then the second level, I'm having header injection, CORS policy. There is a rate limiting, basic authentication, header injection. Then for the databases or the end systems, where I have Salesforce, Workday, I'm having OAuth, multi-factor authentication. Or you could be having a similar policy for all as well. But at each and every stage, wherever there is an interaction, at each and every gateway, basically, the entrance point, we are going to have some kind of security implementation. And that is actually the underlying principle of zero trust security model. Okay. Moving ahead, yeah, so today in the demo, like what we are going to see is we are going to have an end system, and we are going to protect it using JWT policy. So that's just going to be one API, which I already have, and we can see like how easy it is to apply JWT policy to your API. So basically, you can just extend this thing to to your entire microservice implementation. Or you could be having, like, as I said before as well, you do not have to build anything from scratch. You could be already having some underlying security implementation. And as developers, we usually don't go much into the security part. We are more like the security part will be taken care of by the administrator, the security guys and all. But I guess as a developers, it's our responsibility as well to have some basic idea about security, some knowledge as well about security. So we are at least like, we can make out like if there is some security mishap gonna be there, or if there is some violation of policy, there are some loopholes in the system, we can actually alert the seniors, or we can make into like so that we're actually avoiding the bigger destruction, which could be possible. Okay, sorry, there is a password thing. Oh. Yeah, I just forgot. Yeah, talking about security. So, yep, moving ahead. Is there? This is not working. Okay, tools in action. So we'll go ahead with our demo. Sorry, yeah, tools in action, yeah. So this is my API gateway. I would say I have a few APIs here, which you can see. There is fraud system, customer. So these are like only 4 APIs, but imagine you're having like around hundreds of APIs. There are different kinds of API. So as you were speaking before about centralized management system, so you need to have a centralized management system and API gateway, basically, where you're going to have all kinds of APIs. So let me go into fraud system API, because we are actually talking about security and all. And the platform which we are having, so this is an Anypoint platform, which is like a entire like iPaaS tool for managing your entire API lifecycle. We are currently in the API manager where you're going to manage the APIs. So going into the policies, this framework actually provides you a lot of security policies, but you could be having your own mechanism. You could be having your own languages. We're just going to use this as an example, like how you can apply a policy to your API. So we have a fraud system API, and we have a number of security policies. Or you can have any of your custom policy as well, a security policy of your choice. So today we'll see like a jailability validation policy which we are going to apply. I'll click next, and I have to do the configurations. So which again, like whichever language you are having, you can select your signing algorithm. I'll go ahead with the HMAC. I need to have a security, a jailability key as well. So I'll have an AES key, okay, this one, a 256-bit character key, which I'll be just copy pasting it over here. I'll skip client ID validation. So if you have been, I mean, there are so many security policies, basic authentication, JWT and all, and they have lots of claims and everything, but all of them, the best part is they have really good documentation as well. So even as a developer, if you want to go ahead with a security policy, implementing them for your API, you actually have a lot of drivers and like a lot of information present. So I'll just go ahead and apply the security policy to my API. And I can see that the policy has been successfully applied. Now, the next part, I'll be going ahead and creating a token. So this is something, a demo or a static token, I would say. But when you're implementing this thing in real, so just like the way we get this authentication on a mobile, right? And we have to, like the Okta app, and then we can just sign in or we can give access. So similarly, when you're implementing an actual thing, actual jailability policy, you will be having a proper dynamic token. But today, we're just going to generate a static token. So the key, the same key which I had over here, the same key I'm going to like copy paste. Okay. This is jailability.io. It's the official site for developing, for encoding the tokens, for creating a jailability token. I'll paste the secret, and this key has been encoded. So if I go ahead in my Postman, and this is the API. So as we see, the API should have been already applied, and as I have not passed any token, I'm getting error as jailability token is required. Okay, so this makes sure that this is a thing that we have already applied a token. So now let us pass the bearer token. In order to generate a bearer token, we already have an encoded token here. I'll just copy paste this token. I'll paste it over here. And hopefully, it should be giving me back the result. It will validate the token, yeah. So if I would have entered a wrong token, or if there would have been a hacker or somewhere, let me just put this thing, yeah. So I would have got invalid token. So hacker cannot actually hack into my system. And moreover this, like you can see, this is applied for a entire API, for the entire fraud system API, basically. But if you go into the configuration, you can also make it like, I want this policy only if there are going to be like get methods, only if there are going to be like post method. So I don't actually need any security policy for get method or something like that. You can customize at the granular level, and that will be giving you like a more granular or maybe better control on your APIs. And yeah, you can extend this using any of your language, any of your framework, whichever tools you're having. But as you recollect the older mesh-like architecture, we are going to have the security policies implemented at each and every level, at each and every entrance. And let's keep in mind the analogy which we had, like the beginning. At each and every entrance level of your organization, we are going to have a gate pass, and that's actually the security policy which you're applying. With that, yeah, that completes the demo. And this is actually the first time a demo went this smooth and there were no hiccups. And I'm really happy. So yeah, the key takeaways, we have seen what is the need for security, how the organizations have been impacted by security, how there have been always been threats about security and all for your organization, how crucial it is even for developers, for basically for all IT personas to get security into consideration. We have seen what is zero trust security, what are the core principles. We have seen what are the 4 main core principles: never trust anyone, always verify, and then having a full control visibility, giving the least privileges, and the last one was centralized management system. So yeah, we have seen all those 4 principles. We have seen what is the difference between perimeter and zero trust security. We have seen how to implement zero trust security, no matter you do not have to invest more on security part. You don't have to build everything from scratch. You can build on top of whatever you have, but we need to ensure that we have a total security achieved. Just like zero trust security, there are other models as well. You can verify, you can just have your own research on different security model, which suits best for your organization, for your security needs, and how you're going to secure your APIs. We have also seen a quick demo regarding the security. And the next one, yeah. I'm from MuleSoft community. If you want to learn about Zero Trust security or MuleSoft or APIs, you can join our platform. It's for free. I mean, the one where I showed you demo as well. Uh, I recently co-authored a book as well, MuleSoft for Salesforce developers. So if you're someone who wants to learn MuleSoft, you can check it out on Amazon, Kindle. It's available. And we can take all your questions about security, APIs, integrations, MuleSoft. Yeah, the floor is open for questions. Thank you.